Alright. Hello everyone. Let's do the next problem here. Okay, so evaluate division. This one is a kind of a mathy problem, but I'll read it. So evaluate division. You're given an array of variable pairs equation and an array of real numbers where the equations of I for each element I, A, B, where values I represents the equation A divided by B, where A or B is a string that represents a single variable. You're given some queries where queries of J, C, and D represents the jth query where you must find the answer for J, C, and D. Return the answers to all the queries. If a single answer cannot be determined, then return -1. So it's pretty easy to deduce. Like these ones, they don't exist. So yeah. Okay, so I think the relationship here is like this. So we have A and B. B represents A divided by B, and then B and C represents B divided by C equals 3. So let me write this out. So so we have this here, right? This is basically representing A divided by B equals 2. B divided by C equals 3. From this statement here, then we can just deduce, well, okay, I was thinking of solving them out, but, okay, and then the query is saying AC, so we have A divided by C. So what is this? Well, I can solve for, this is basically saying like, so we have C over B equals 1 over 3. And like the inverse, we have that information. So, right, B over A equals 1 over 2. So CB 1 3, BA 1 2. Then from here, A of C equals, I don't know actually. Let's see. That's basically saying C over B, B over A. Which is, that's equal to, well, this is basically saying 1/3 times 1/2. Yeah, C over A, which is 1 over 6. 1 over 6, we can say A over C is equal to 6. Yeah. I mean, we have that, so that was kind of weird. Um, well, let me see this. We have A over B equals B over C, which is exactly what we want, which is the product of these two. Okay, so we have, okay, I get the graph now. So the graph is basically, for every single letter, it's like a double directed graph. A directed graph from A to B is saying from A to B, we're saying A over B, And then from B to A is we're saying B to A, which is also the result, which is 1 over 2, and we're saying 2. And then do that for C as well. So this is saying B over C, which is equal to 3. This is 1 over, this is C over B. C over B, which is equal to C over B, which is equal to 1 over 3. And basically when we say, okay, I want A over C, so we need first A, we'll do 2. So we go to A to B, then to C. Right? A to B to C. A to B to C. So we start from A, basically that's the start, the source, and try to end up at C. And as we traverse the graph, we kind of sum them up or multiply them up. My intuition says to multiply them, right? We go here, A to B, which is result 2. Then B to C, that's 3. So 2 times 3, which is 6. The result is 6. I don't know if that's true, though. Now, B to A. So first we start at B. Then we go, we try to find our target. Like, I can try to go to C, but then that would just lead me to the wrong direction, right? Try to go to A. I have like a target and source. Maybe I have to do BFS to the thing. So I can probably try to go this way. And that prunes. But we go this way and that actually gives us the answer. So B to A. Yeah, 0.5. Let's do a more complicated one. A to E. There's no such thing as that. A to A. So we go to A, which is 2. And then we end up at A. I think I can hard code this. This one's like if the query is equal to itself, we just return 1. I don't think I need to traverse the graph. Then X to X. Yeah. Maybe I could do like a BFS function. So I find like the shortest path to the target. Let's do another one. So let's say 1.5. Is it sum or I don't know if it's sum or not. Oh my god, what is BC, DC? I have to do B times C and C times D. Oh my god, this is kind of crazy. This is more of a math problem than an actual LeetCode. Oh, is it just a character? Like as a single unit, right? Like BC, CD, 2.5 divided by 5.0. 2.5 divided by 5.0. 0.5. Okay. Oh shit. That's wrong. Oh man. Wait, no. What am I saying? No. That's not what it's saying. Oh, we're saying BC is equal to 5.0. Okay, no, I don't have that actual. I hope this BCCD. Yes, 5.0. Okay, never mind. They're just characters. They don't represent multiplication. Okay. So yeah, I basically just, these are a single unit. So these are like, I guess names. Names represent like an equation. So this name divided by this name, right? And my guess is to add or multiply them. I'm saying multiply as you go to the target, you know? Maybe a priority queue? I'm not sure. Yeah, I think we just do basically DFS on every single query, as where the start is obviously here, the start and end, and basically calculate the like the product from it. So let's try it. Okay, so let's build a graph where graph is just default dict a list, and for every equation in equations, I actually prefer where a we'll do like call it a b, graph of a b equals a divided by b, or actually graph of values of I. Actually, probably prefer to zip this. Do this, and then we'll do zip. Well, let's do the opposite. Divisor, and then val zip with the values equals val, and then we'll do the inverse as well. So we have like the opposite direction from B to A. Yeah, B to A. Wait, does that make sense? Yeah, divided by. Oh wait, what am I doing? Wait, BA. Yeah, so val, and then 1 divided by val. Yeah, there you go. Yeah. So let's see this. Print graph return. Bro, what is wrong with my keyboard? Wait, shouldn't I have like dot appended? Yeah, hold on. Dot append. Bro, I'm getting mad at this. Super annoying. Why does this happen again? Okay. I don't know what's happening with my keyboard. Bro, I keep pressing it for some reason. Is it this? Why does that fucking happen? Should it be like... Wait, why am I... Okay, no, I should have a dictionary. Because I basically want like A, then to B, to... Like I want like something like this. Like A to B to the value, which is val. And A could have another one like C here, which is like, I don't know, 2 or something. A divided by C is, well, okay, not necessarily. It could be something else. But generally speaking, like B divided by A, A will equal, I don't know, 3, right? And this would be, well, B divided by A is actually just 1 over 2. Okay, yeah, B divided by A divided by B, which is just 2. Something like this. This is kind of the idea I'm trying to go for. So let's actually put that here instead of a dictionary. It's supposed to put a yeah, let's put a dictionary. So we put the value. divided by A. So A divided by B and B divided by A is basically the inverse, and we have every single value we can have here. Okay, now let me print the graph, return just a list of nothing. Okay. Okay, what is fucking happening? Okay, how is that better? Okay, so we have here the dictionary A to B, B to, yep, exactly, that's exactly what we want, 0.333. C divided by B. We also have B divided by A and B divided by C. Yeah, that's what we all want. Because B goes to A and B goes to, and yeah, A goes to C, or A goes to B. B goes to, actually B goes to this way and this way, yeah. Because since B's in the middle, it should go to both direction A and C. Yeah, that makes more sense. Okay. So now we have our graph. Basically, we just kind of do like a DFS on every single query. So like for every query in query, I prefer this here. Let's do A to B here. Let's call this actually start target, or yeah, target. And as you go along, we'll do that. And we'll have like a res here. Return res. And res.append is basically the DFS from start to end. And we'll add a set as well. Bro, I don't know how to turn that off. Okay, anyways. Okay, basically, yeah, the result of that. And then, yeah, that's basically the code. Now, it's very similar to last time, so yeah. Then we'll do def DFS. We'll retake DS and a scene. Let's call it, let's be more descriptive. Start, end, or target. Okay, so basically, two base cases. If we have seen the, if start equals target, right? Or yeah, if they're the same, then we just return 1, right? If start not in graph, or end not in graph, turn -1. Pretty straightforward. Those are the base cases. Like if any of those are not in the thing, then that's bad, right? So we return -1. Okay, then honestly, I could probably get rid of that, but I think it's nice to have it in a DFS. Actually, yeah, let's prevent that from ever happening. The base case is actually just start equals target. If start not in graph, or target not in graph, res.append res, or -1.0, else do this. Yeah. Perfect. So now the base case is basically once you've reached the thing. And that's basically saying start, like we're trying to get the, like, okay, we found the one, what is that? Basically, it's not affect the answer. We just basically find the one. Basically, we want to multiply all across as we traverse the tree. So now basically the traversal parts of every neighbor and graph of start scene.add not neighbor, I guess start, and then we call DFS we'll call DFS on the neighbor as the start, and then the target, and then the scene. And then we should actually we want to be recursive, so we want to multiply all across. So we'll do res here, and if, oh, okay, actually, never mind. I need this here. Actually, it's fine. If a res equals 1.0, or actually, if it doesn't equal, no, I need this actually. I need this to be here, because if we end up in a bad spot, like whatever that, like I could have gone traversing, like I could have tried to traverse like so I wanted to find b over a, right? That's right here, b over a. I could have went starting from b, went to c, and then that wouldn't be a negative, but it's not the target. So I mean, I guess, but it's not the target, so we would keep going, and it would return something else. So I feel like I still, no, wait, do I need this actually? No. Yeah, basically if and only if that, then we return the res times the graph of start and neighbor, because that is the resulting of, we found the base case, right? Basically the accumulation of 1 times this times that, yeah. And then if we can't find anything, we just do -1. Yeah, actually I do need it, because if I don't reach the target and there's no more any values, then return -1. Actually, no, I don't need it. I just prevent it from the start. Yeah, I prevent it from the start. I don't ever search from bad like starting points or ending points. And then if start equals that, then we do that. And then if it doesn't equal a -1, we're Gucci. We do the result to that, and then it will return us something, and then we can return the result. I want start your target. Akili. Okay, maybe I do need a safeguard here. Let's add this here. I return -1. And then we just prevent this from ever. We don't need to do that. We'll return it out anyways. Oh shit, hold on. I forgot something. I need to prevent it from revisiting. Oh my god, no. Wait, I messed something up. Okay, I have a scene, but I don't use it. Why don't I use it? If neighbor in scene, skip it. No need to traverse that. There you go. Perfect. See you guys tomorrow.